Hello everyone. So let's start with the second chapter, design principles. First of all, we will discuss about the introductions. The basic aim of the structure design is safety, serviceability, economic. The structure should be safe under worst loading condition. The deformation, deflection, and the cracks under the working load condition should not affect appearance, durability, performance during its intended lifespan. The structure should be economical with regard to first cost and its maintenance. Design codes. uh, Design codes, codes are the set of the technical specifications which serves as a guideline for the design of the structure. Codes are drafted by the expert structural engineers using the results of expensive researches and practical knowledge. These codes are periodically revised to bring them in line with the current research and often current trends. Many countries have drafted their national codes. All the reinforced concrete structures designed in our country should conform IS 456 2000. What are the objectives of codes? So basically, these codes are the booklets we use for the reference of the different values which are already calculated by the researchers for safety and design purposes. What are the objectives? To provide the adequate structural safety by specifying certain essential minimum requirement for the design, to provide the designers a relatively simple design procedure, to provide a uniform set of the design guidelines to followed by various structural designers in the country, to provide legal validity and to protect the structural engineer from any liability due to failure of the structure caused by the inadequate design and improper material and the lack of the proper supervision during the construction. Method of the design. So there are two different methods by which we design. The one is the ancient one, which is working stress method, and the old this is the oldest method which we are using. And the second one is the limit state method. This limit state method is the latest one, and we basically use this one for the designing of structure. What is the working stress method? Working stress method was developed during the beginning of the 20th century. This method is also known as elastic method of the designing or modular ratio method. The working method is simple in concept as well as application. So basically, working stress method is based on the experiences and a different kind in the different kind of the structures. The working stress method, the working stress is based on the behavior of the structure at the working load, the stress distribution in the concrete and steel at the working load is assumed to be linear. It is assumed that the stress in the concrete and the steel does not exceed their permissible values at the working load. So here you can see this in this method, it is assumed that the values of the stress in the steel and concrete will not exceed to the permissible values or the maximum values, but in actual it increases, and when it increases the structure fails. The permissible stresses in the concrete and the steels are obtained by dividing the characteristic strength of the material by the factor of the safety. The factor of the safety of the concrete in compression in bending is 3. The factor of the safety of the steel in tension is 1.8. Factor of safety allows for the uncertainty in the estimation of working load and the variation in the properties of the material. The working stress method is referred as the deterministic because it is presumed that the loads, permissible stress, and the factor of safety are known accurately. So, assumptions in the working stress method. The working stress method is based on the following assumptions. Concrete is assumed to be homogeneous at any cross section. Sections will remain plane after bending. Tension is entirely taken by the steel, none by the concrete. The modulus of elasticity of steel and modulus of elasticity of concrete are constant. The steel area is assumed to be concentrated at the center out of the steel area. There is a perfect bond between steel and concrete, and no slip take places between steel and concrete. Concrete area on the tension side is assumed to be ineffective. Modular ratio M has the value 280 by 3 rho CBC. So here is a diagram which shows that how the stress strain curve in the working stress method. Here you can see this AST is area of steel, and this is the X distance, and the total depth is D which is also called effective depth, and this is a strain diagram, and this is a stress diagram, and the axis, this axis is called neutral axis. These are the definitions. B is the width of the section, D is the depth of the section, AST is the cross sectional area of the steel, D is the effective depth of the section, X is the neutral axis, sigma CBC is the permissible compressive stress in the concrete in the bending, sigma ST is the permissible tensile stress in the steel, epsilon C maximum compressive stress in the concrete, epsilon S maximum tensile stress in the center of the steel. Drawbacks of the working stress method. Concrete is so there are many drawbacks. Which few of them are: concrete is not elastic, the mild steel behavior as an elastic material, but HYSD bars do not behave elastically. The factor of the safety does not give true margin of the safety against failure of the structure. For example, a factor of safety of 3 for the concrete does not means that the member of the structure will fail at the load 3 times the working load. Creep and shrinkage, which are major time dependent effect on the structure, are accounted by the elastic theory. The additional load carrying capacity of the structure due to redistribution of the moment cannot be accounted for. The actual safety against ultimate load is not known. So the second method is limit state method. In the limit state method, the structure is designed to withstand safely all the loads liable to the act on its throughout lifespan. Therefore, collapse of the structure will not take place. So in this limit state method, we calculate all the possibilities for its lifespan, satisfy the serviceability requirements such as limitations on deflection and cracking. As such, the failure of the structure will not occur due to the excessive deflection, cracking, etc. Limit state method is based on the safety or the ultimate load. So this is the maximum. This is also called the maximum load which a structure can face during its lifespan or serviceability. The acceptable limit state limit of the safety serviceability requirement before failure of the structure taken place is known as the limit state. A limit state is a state at which one condition related to the structure attains a limiting or critical value. The important limit state which are to be considered is design as limit state of collapse, limit state of serviceability, or other limit states. The design of the structure is based on the characteristic value for applied load and the strength of the material. Design value are obtained by applying partial safety of factors to characteristic strength of the material and characteristic loads. The limit state method is referred as non-deterministic method. So here is the comparison between the limit state and the working stress. In working stress method, it is based on the behavior of the structure at the working load. In limit state method, it is based on the behavior of the structure at the different limit state, ensuring adequate safety against each limit states. In working stress method, it is referred to as the deterministic method. In limit state, it is referred to as the non-deterministic method. In working stress method, factor of safety is applied to yield the or ultimate stress. Method, partial safety factors are applied to characteristic value to get design value. In working stress method, it is based on the linear stress distribution. In limit state method, it is based on the non-linear stress distribution taking into consideration. Working stress method, actually safety against ultimate loads not known. Limit state method, it overcomes the drawbacks of the working stress method. So there are the different limit states which we use for the safety of the structure. The first one is limit state of collapse. This limit state is introduced from the safety requirement. The limit state is reached when the structure as a whole or a part of the structure collapse. Limit state of collapse in flexure, limit state of collapse in compression, limit state of collapse in shear, limit state of collapse in torsion. And the second one is limit state of serviceability. This limit state is introduced to prevent objectionable deflection and cracking. Limit state of serviceability related to the satisfactory performance of the structure at working load. Two important limit states of the serviceability are limit state of deflection, limit state of cracking. Limit state of deflection. The deflection of the structure under service load condition should be within the acceptable limit. It creates feeling of lack of safety. Aesthetic view is spoiled, creating ponding of the water on the roof it leads to deformation of the doors and the window, it leads to the separation of plaster finishing and cracking of the floor finishing material. Limit state of cracking, spoiling the appearance, creates a feeling of lack of safety, creates leakage problems leading to corrosion problem affecting the durability. And the third one is the limit state, other limit states, uh, which are limit state of vibration, limit state of fire resistance, limit state of impact resistance, limit state of durability. So the next one is the characteristic strength of the material. The strength of the material below which not more than 5% of the test results are expected to fall is known as the characteristic strength. So basically this is the when 95% of the test of the material passes and below 5% material fail is called the characteristic strength of the material. So here is a chart is showing how frequency distribution curve for the strength. So the next one is the characteristic loads. The characteristic load is that value of load which has 95% probability of not being excluded during the life of the structure. It is denoted by F, and here is the curve distribution, frequency distribution curve for the load, where Fm is the mean value of the load and S is the standard deviation. Partial safety factor, or it is also known as the factor of the safety. These are the factors which are applied to characteristic load, and the characteristic strength of the material gives design value. There are two partial safety factors, one for the load and another for the material. Partial safety factor for the load, the partial safety factor for the load is a factor by which the characteristic value are multiplied to get the design value for the load. The partial safety factor for the load is denoted by gamma f. The value of the gamma f is dependent upon type of the loading and the number of the loading acting together. Importance of limit state. So these are the tables for the partial safety factors and its combinations. Like load combinations are dead load plus live load, and next is the limit state of the collapse, limit state of the serviceability, and the which value of the partial safety factor we can use for load calculations. And the next one is the partial safety factor for the strength of the material. The partial safety factor for the strength of the material is the factor by which the characteristic strength of the material is multiplied to get the design value of the material. The partial safety factor for the strength of the material is denoted by gamma m. The partial safety factor for the strength of the material takes into account the possible difference between the strength of the material in the actual structure and the strength obtained from the test specimens, the possibility of reduction in the strength of member due to insufficient compaction, improper curing, etc., the possibility of reduction in the strength of the steel bars due to measuring defects, for example deviation from the nominal diameter and the inaccurate position of the steel. And here is the partial safety factor for the table for the material. And the next one is the design values. The design values are obtained when the partial safety factor are applied to the characteristic strength and the loads. These are obtained as below. The design strength of the material Fd is equals to F upon gamma m. F is the characteristic strength of the material, gamma m is the partial safety factor, which we are taking as 1.5 and for the concrete and 1.15 for the steel. Loads. The design load Fd is given by Fd into F into F is the characteristic load, and gamma f is the partial safety factor. Design stress strain curve. We already learnt about the stress strain curve of the materials, and here is the design stress strain curve in which you can see design stress strain curve for concrete in flexure compression, and different curves. They all are parabolic. The first one is for idealistic curve, the second one is the characteristic curve, and the third one is the design curve, and with different stress values, strain values and stress values on the y section. Reinforcing steel. Mild steel bar. For mild steel bar of grade Fe 250, the stress is proportional to the strain up to yielding stress, and therefore the strain increases at the constant stress as shown in the figure. and this is shown in the figure. And therefore after the strain increases at the constant shown in the figure, the mild steel has definite yield point. For the mild steel, the changes of the elastic to plastic conditions is abrupt. The partial safety factor of the strength of the material is 1.15. Therefore design of Fy 1 point divided by 1.155 is equals to 0.87 Fy is used for the mild steel. These are also the tables for the design stress strain curve for high HYSD bars, high strength deformed bars, and the last one is the high strength deformed bars. In case of HYSD bars of the grade Fe 415 and Fe 500, which has no specific yield point, the change from the linear elastic behavior to the non-linear behavior is assumed to occur at the stress level equals to 0.8 Fy in the characteristic curve, and 0.8 into 0.87 Fy is equals to 0.696 Fy in the design curve. Here you can see all the values and how curves are changing here, and these are the characteristic curve and the design curves. Characteristic curves are shown with the dashed line and the design curve is shown with a solid line, and this is the stress value and these are the strain values showing here. And at the end some filling the blanks and their solutions, and some of the these filling the blanks with their solutions, and some of the theoretical questions for practice. If you find any problem, you can ask me personally or comment in the comment section. Thank you very much.